All right, so we're going to be looking at problem 2.1 in CMP patterns and variables, or variables and patterns rather. So here's what we're going to do. So we're going to set up our notes and we're going to be on Desmos at the same time. So you're going to log on to Desmos. The code for the activity for this is, I'll write it over here. The code is 9xbdth. So you're going to go to student.desmos.com. You're going to sign in there. And then you're going to get started. And what we're going to do is we're going to be working on Desmos on the right here. And then we're going to be showing our work and taking some notes over on the left. There's a few things that we need to take notes on, and then it'll also give us a place to work out some of our math as well. All right, so we're going to start with our Desmos activity. Real simple. It's asking how we're feeling today. It gives us our check-in bot. Right now I'm feeling pretty good. Obviously scared of the whole pandemic thing. But I'm excited by how Flipgrid is going. I love getting to see everyone's faces again. That's my check-in. So feeling pretty good. You know, I'm on the positive side on our check-in bot for sure. All right, so do your check-in. And remember, a lot of times during this video, I'm going to ask you to pause and do your work and then come back to the video. So if you don't just sit here and copy what I do, right? You should do it for yourself. That'll make this a lot better and a lot more helpful for you. All right, so we're going to slide number 2. So slide number 2 has the introduction for this investigation. It says in this investigation, we're going to build on our work from investigation 1. We're going to use tables, graphs, and words to analyze information from our research and advise the tour business partners. It says in problem 2.1, which is the problem we're going to be doing today, we're going to be using tables and graphs to figure out which shop is a better deal for renting bikes for the bike tours. And we're going to be focused on figuring out 2 questions. 1, which shop would we recommend? And number 2, how would we justify our choice? All right, so remember, those are our 2 questions. I'm actually going to write those questions on my notes. That our question 1 is, which rental shop do we recommend? And question 2 is, how can we justify our choice? So that's our focus for today. We'll know when we're done if we can make a recommendation. That's when we'll know that we're done with our work for today. All right. So it asks us first, it says on the left is a table from Rocky's Cycle Center for how much it costs to rent different numbers of bikes. Based on the data table and the information in the problem so far, what are the variables in this problem? And remember, a variable, we said, is a quantity that can take on different values. So we already have that in our notes from before, but if you want to add it again, we said that a variable is a quantity that can take on different values. Okay, so this is asking us what are the variables in our problem based on our graph up here. Okay, so try this one for yourself. Pause me. I'll give you a few seconds, and then we're going to go over it together. So I'm looking for, based on this graph here, what are the variables I see? What are the quantities that I see can have different values? So when I'm looking at that, I see 2 on the chart for this problem. I see in this problem, the variables are the rental cost, which is, in this case, over here, right? I'll underline it instead. And then the other one that I see is the number of bikes, which is this other one. So we know that the two quantities that can change are the rental cost and the number of bikes. All right, so I'm going to enter that as my answer here. Rental cost and number of bikes. Cool. Share with class. All right, so we know what the two variables are for this problem, rental cost and number of bikes. All right, so it introduces us to a new term. So it says many real-world situations have two variables where one variable depends on the other. For example, this problem has two variables, number of bikes and rental cost. The quantity that depends on the other quantity is called the dependent variable, and the quantity that depends on is called the independent variable. Now, I don't think that those are super useful definitions, so we're going to actually take notes on our own definitions over on our notes. So it gave us two new words that I'm going to add to our notes. The first new word that we're going to add is dependent variable. And in our case, a dependent variable is a variable that depends on another variable. And the independent variable is the variable that the dependent variable depends on. So a good summary statement that we can add to our notes is that the dependent variable, I'm going to make a little star because it's a key note. The dependent variable depends on the independent variable. So that's an important point. The dependent variable depends on the independent variable. So we're going to actually talk we're going to talk plenty more about that. So if you're like confused about what those words mean or confused about how we might use them, that's totally fine and understandable. We're going to get some more practice with them coming up. So this next question asks us, which variable do we think is the dependent variable in this problem? So from the last slide, the quantity that depends on the other quantity is called the dependent variable, and the quantity that it depends on is called the independent variable. In this graph, or table rather, which variable do you think is the dependent variable? Which variable depends on the other one? So take a second to make your choice, and then we can check to see if we agree. So I'm looking to see which one depends on the other. Does the number of bikes depend on the cost, or does the cost depend on the number of bikes? So in this case, I'm going to say that that the cost depends on the number of bikes, which means that the cost is the dependent variable, right? So the cost depends on the number of bikes you rent. So the cost is the dependent variable. That means the number of bikes is the independent variable because the cost depends on it. So we're going to add that to our notes here. So we can say that in our problem, the cost depends on number of bikes. So cost is the dependent variable. We can say that cost is dependent. Number of bikes is independent. So cost is dependent, number of bikes is independent. Because the cost depends on the number of bikes. We're going to work on more skill practice with like dependent versus independent. Just I want to introduce you to that term because we're going to see it a lot coming up. All right, so the next slide just kind of reviews what I was saying here. It says for this problem, we should say that the number of bikes rented is the independent variable. That means that the rental cost is the dependent variable. The rental cost is the dependent variable because the cost to rent bikes depends on the number of bikes you rent. And if you got this wrong on the last slide, go back and fix it so that I know that you read the correction and that you realized your mistake and that you made a change, right? That tells me that you're trying to make a change and show that you learned something. All right, so number 7 is going to kind of introduce us to the other shop, right? So we've gotten a chance to look at Rocky's Cycle Center. That's our first shop to rent bikes from. Our second one is Adrian's Bike Shop. So this says, this is a graph of how much it costs to rent different numbers of bikes from Adrian's Bike Shop. You'll notice that this graph has the same two variables as the table for Rocky Shop, number of bikes and cost. The number of bikes, the independent variable, is on the x-axis, the cost is on the y-axis. Graphs usually have the independent variable on the x-axis and the dependent variable on the y. That seems like an important point, and so I'm actually going to add it to my notes. So I'm going to add it down here. On graphs, the independent variable is usually on the x-axis and the dependent variable is usually on the y. So if I were, it's actually going to shrink this really quickly. If I were trying to, if I were drawing like an example graph, I would show, I would show that the independent variable is on the y, or on the x rather, and on the y would be the dependent variable. All right. So we said usually the x-axis is the independent variable, usually the y-axis is the dependent variable. So we added that to our notes. All right, so remember that the goal of our work is to figure out which shop is the better deal. So which shop would recommend, how would we justify our choice? And so we're going to be looking at each shop individually, right? So let's start, we just looked at Adrian's, let's start with Rocky's Cycle Center for the table here. So it says on the left, you'll see data from each shop on how much it costs to rent different numbers of bikes. So what patterns do you see in the table from Rocky's Cycle Center? And what do those patterns tell you? So your patterns are going to depend on what kind of things you notice. I'll give you a few seconds to pause so that you can try it on your own, and then we'll see what goes on here. Okay, so if I'm looking at this table, what patterns do I see? Well, I see that the cost goes up when you rent more bikes, which makes sense. I also see that when you rent 5 bikes, the cost is $400. When you rent 10 bikes, the cost is $535. So what that tells me is if you double the number of bikes, you don't double the cost. So if you double the number of bikes you rent, you don't double the cost. So what that tells me is that it's cheaper, maybe it's a better deal to rent more bikes because you pay less per bike, right? Because if I rent 10 bikes, I only have to pay $135 for that extra 5 bikes when I paid $400 for the first 5, which is kind of weird. So those are some of the things I noticed. I'm sure you noticed other things. I'm gonna hit share with class. And then it's asking us, what do I notice for Adrian's bike shop? Well, I noticed that the cost also goes up when you rent more bikes. Let's try that same test from before. When you rent 5 bikes, the cost is it's a little bit below 200. I think it's probably like $180. When you rent 10 bikes, the cost is, I don't know if I can tell exactly. It looks like it's between 200 and 400. So I'm going to say, because I'm looking at, that was cool, but not what I wanted to do. I'm looking at this thinking like, it looks like there's each line is worth $200 since it takes 2 grid lines to get to 400 on the y-axis. So I think that for 10, the cost is about, $350 is my guess. So, that's pretty close to double, right? I would think so. Like it looks pretty close. Like if you double the number of bikes you rent, you about double the cost. So it's not a much better deal to buy or to rent rather lots of bikes because it's pretty much going to cost you the same amount, which is different. Some people might also notice that these points make a line. I think there's a lot of people, we called that linear before. I think some people might make other noticings, but that's what I was looking for. So it's asking us, it says how we can use patterns. So it says, remember that patterns in tables and graphs allow us to do all kinds of things with the data. We can figure out one variable from another, we can describe the relationship between 2 variables, and we can even make predictions about data that we don't have. So next it says we're going to try some problems that are going to ask us to use the patterns we see in the tables and graphs to find information about the cost of renting bikes from each shop. So we're trying to figure out how much does it cost to rent bikes from each shop using the data that we have. So the first one says, what's the cost of renting 20 bikes from each shop? And we have to put them in the table here. So let's see what I notice. So for Rocky Cycle Center, if I'm trying to figure out how much I pay for 20 bikes, it's right in the table. So it cost me $770. All right. Adrian's 20 bikes, this is 20 bikes, so I'll trace right up. That's halfway between 400 and 800, so I'm going to say it's 600. Because I have 400 and I have 800. If I'm thinking of it on a number line, then I'm going to say this is probably 600. All right. So Adrian's Bike Shop about $600, Rocky Cycle Center about $770. So it's cheaper for Adrian's Bike Shop. That's interesting. All right, it says, what about 40 bikes? Well, again, it's right there in the table here. So Rocky Cycle Center is going to be about $1,140. For Adrian's 40 bikes is going to go up here. That's about $1,200, I would say. I know my lines are a little bit crooked, but okay. So go to the next one. It says, based on the data for each shop, what are the costs of renting from Rocky and Adrian if the tour needs 32 bikes? Pause here, see what you think. This one's kind of hard because 32 isn't in the table and it's not on the graph. Okay, hopefully you gave it a try on your own. I'll tell you what I'm thinking personally, which is, okay, 30 and 35, so I guess 32 would be somewhere kind of between there, right? So I'm thinking between 975 and 1070. So if that's 975 and that's 1070, it's like somewhere in the middle there. I guess a little bit closer to the 975. So I'm going to say, I'm going to say like 1,020, I guess, dollars for Rockies, or sorry, for 32 bikes from Rocky's shop. And then how much is it for Adrian's? That's what I'm wondering. So Adrian's is a graph, so I guess I'm looking at, here's 30, here's 35. So if I'm drawing a straight line from 30, so 30 is right there, 35 is right there. So it's somewhere between here and here. So I guess it's pretty close to, it's like a little bit under, it's like 1,000 or like a little bit under 1,000. So I'm going to say a little bit under 1,000. We're going to call that 900 and, I don't know, 950. So $950 for 32 bikes from Adrian's shop. And how did I figure it out? I figured it out by finding the cost for 30 bikes, and 35 bikes, and finding number in the middle of each. So I kind of just did like 30 and 35, and then I figured out a number in the middle of each. All right. So it says, how can you predict, this is kind of a summary question, how can you predict the rental costs for numbers of bikes that aren't shown on the entries in the table or the points on the graph? For example, think back to how you figured the cost of renting 32 bikes. How would you predict the cost of renting 100 bikes, 200 bikes, or some crazy number like 432 bikes? So it says you don't need to give answers, but do try to describe how you could use the tables or graphs to predict the cost for a number of bikes that isn't in the table or graph. So give yourself, a couple minutes to write an answer for this, to write kind of a summary of what you could do, and then check and see if it kind of jives with what I have. And I'm going to write while you're working. All right, so hopefully you came up with some answers on your own. This was a tough one for me. So I said that, so the question was, how can you predict the rental costs for numbers of bikes that aren't shown in the table or the graph? And I said we could use patterns from the tables and the graph to make predictions. So I said if we know that 10 bikes is a certain cost, we could like predict the number of the cost for 100 bikes by like using an equivalent ratio. Like if we know 10 bikes is $100, we could like times the cost by 10 for 100 bikes, I guess, sometimes. Or I also said that we could maybe draw out the table or the graph, like extend it until we get to what we want. Like I could take this graph over here and like keep, make a bigger version to get to more bikes to see like what the cost would be. And I said sometimes we can even like make a rule that tells us like, oh, it's, $20 per bike. So then I could use that to figure out the total cost. So, but I'm excited to see what patterns or what answers you came up with for that one. All right, so we're going to work on slide number 16. It asks us, based on the data for each shop, how many bikes can we rent for $400? About how many bikes can we rent for $400 for each shop? So take a few minutes here to work on that problem before checking with me. If I'm looking to see how many can I write, well, okay, so for Rocky's shop, I know that I can see in the table that the rental cost is exactly $400 for 5 bikes. Now for Adrian, I'm going to say for $400, which is right here, you could probably get, I guess it's a little bit, like maybe like 15 bikes, because it's between 10 and 20. And it says, explain how we could figure it out. So for Rockies, right? How did I do it? I guess I looked at the table for the number of bikes rented for a cost of $400. For Adrian, I looked on the graph for how many maybe I should say for the number of bikes that was closest to a cost of $400 on the y-axis. So I looked to see which one was close to $400, and I used that to make my estimate. Cool. I'll hit share with class. I'm moving on. All right. Number 17 asks, it's a very similar question, but it's asking us for $900. Okay, well, let's look for Rockies. Try this on your own, and then come back and check with me, but I'm going to start with Rockies. So 900 isn't in the table up here at all, but I do notice that 900 is between these 2 points. So it's between the cost for 25 bikes and the cost for 30 bikes. So I'm going to say Rocky, between 25 bikes and 30 bikes, it looks like it's closer to 25. So I'm actually going to say like 26 bikes because $900 is between the costs for 25 and 30 bikes, but closer to 25 bikes. And then for Adrian's, let's see. If I'm looking for 900 on the graph, well, I know that this is 800, and I know that this is 1,000. So I'm going to assume that 900 is between 800 and 1,000, so like somewhere in there. Oh, and there's a dot right there, it looks like. It looks like there's a dot on $900, so, and that dot is right there. Oops, this will be easier. Right there. So and that looks like it's at 30 bikes. So I'm going to say 30 bikes because on the graph, the cost for 30 bikes was about $900. Oh, okay, so that one worked out kind of nicely. It's about $900 for 30 bikes right on the graph. So in both cases, it looks like you get more bikes for your money for Adrian. So it says, how did you use the patterns in the table in the graph to figure out how many bikes you could get for a certain cost? I'll give you a minute or two to summarize, and I'll type up my answer while you're working, and we can check to see if we agree. All right, so your answer might be different than mine. I described the strategy that I used, which was I tried to find like an above and below estimate by looking for like the costs that were on the graph in the table. Like I was trying to look in the graph in the table for costs that I did know, and I tried to use those to work backwards to the costs that I didn't know, either by find one that's too high and too low, and then find one in the middle. Is how I did it, but there's some other ways to do it too. I'm sure I'll see in your answers. All right, so this one's going to again depend on your opinion. It says, but I mean, there's good evidence for both. Which data format, graph or table, do you think was the most useful, and why? What information was easier to get from the table? What information was easier to get from the graph? So you can work on this your own, and you can tell me which one you think was more useful. I think the table was more useful for finding specific costs and numbers of bikes. But the graph was more useful for finding a pattern between the costs, and more useful, I think it was more useful for figuring out the costs for numbers of bikes that weren't in the table or points on the graph. So like if there was something that I needed to make like a prediction about, I think the graph was easier to use to make predictions. But we could disagree on that. I think it depends on kind of how your brain works. But for me, the graph was easier to make predictions. Like if I wanted to know, oh man, how much does it cost for 15 bikes? Or let's choose a weird number. Let's say like 23 bikes. It's easier for my brain at least to say, okay, I can draw about 23, and I can kind of figure it's probably here on the graph, right? That made more sense to me. but you might be different. Share with class. All right, let's summarize. Since the Ocean Bike Tours need to choose a bike rental shop, suppose they ask for your advice. Which shop would I recommend, and how would I justify my choice? I think this is a really tough question, and I should start by saying that I think that you could pick either answer, but you should pick the answer that you think is right and write an explanation before you see what I think. So I'm looking back and I'm saying, okay, I could get more bikes from Adrian's. The cost for 32 bikes was better for Adrian's. Cost for 20 bikes was better for Adrian's. The cost for 40 bikes was better for Rockies. So I guess what I'm thinking is, it seems like Rockies is better if I'm renting a ton of bikes. Adrian's is better if I'm only renting a few. So I'm going to guess that a bike tour shop is going to have to rent a bunch of bikes. I'm going to say Rockies. So I'm going to say, but when I explain my thinking, I'm going to try and be as clear as I can be. So I think that Adrian's is the better deal for cost per bike if you rent a lesser amount of bikes, like less than 40. But Rockies is a better deal if you're renting a lot of bikes, which I figure a bike tour would need. So I think a bike tour would need more than 40 bikes, so I'm thinking that Rockies is the better deal. This is because we can see in the table that Rockies bikes get cheaper the more you rent, where Adrian's don't. It doesn't seem like it to me. So I'm going to hit that to share with the class. To me, though, this makes me wonder if you're somebody who's like looking for a challenge or looking for a really interesting math question. And I guess what I'll do is I'll post this as an optional thing on Classroom maybe. If I don't do that, somebody remind me. But I think a really interesting question to consider, and you don't have to write this down, but is how many bikes do you need to buy let's change buy to rent. How many bikes do you need to rent to make Rockies shop the better deal? Because we know that if you rent 20 bikes, Adrian's is the better deal, but if you rent 40, Rockies is the better deal. So how many bikes exactly do you need to rent before Rocky's shop becomes the better deal? And how can you prove your answer? I think that's a really, really good question. So if you're kind of like a math theory person, or if you're someone who likes a challenge, that might be a good challenge problem for you. In fact, might go back and add it to our activity as a challenge. All right, so challenge problem aside, we're pretty much done. So the last slide that you have to do is a checkout slide. So it says drag the point to the location that represents how you feel about the math. So to me, it's making some sense. I've got some questions about independent and dependent variables. As far as interesting, actually, I think this is kind of interesting. I think it's interesting to learn to try and figure out better deals. I think that's a practical skill you can use a lot in life. So and just the math is interesting. So I'm not going to elaborate on my response, but that's where I'm going to leave it. All right, so check out on there. So when you go to look for the activity on Desmos, use the link on Classroom just in case I have to change the code that's on the activity. But I look forward to seeing what you guys come up with, and hopefully we get a chance to kind of discuss some of our answers later on in the day too. So look for my feedback on the activity as well at the top of the screen. Look for the little messaging icon to see what kind of feedback I leave you. And make sure you put these notes on the left here someplace where you can find them later. All right, thanks guys.